Uh, in the last recording, we looked at the emergence of the concept of water security by briefly referring to the first part or first half part of the Karen Baker's paper. We did not touch upon the critique which she has presented in the later half of her paper. This recording is going to focus on some of the indicators which are present in the water sector and also the shortcomings of it and the concept of blue water and green water coined by Marin Falkenmark. Many of you might be knowing her name already. She is a very notable water scientist in the water scholars community worldwide. And then how her thinking is relevant to the measurement of water from the security point of view, the water security point of view. So that's the focus, and we'll once again begin with indicators and the need, different kind of audiences, different indicators addressed to, etc., etc. But before I start talking about indicators, let me once again emphasize that water security, although tries to, the concept of water security also tries to capture the availability, scarcity, sufficiency, sustainability kind of concerns in the water sector in the form of an index or a measurement. It is only one small part of the entire water security debate. So there are various angles with which people have looked at or tried to understand the water security as a concept and its scope. And this book by edited by Mark Zaitun and his colleagues, which I have already uploaded on the TESOL page of this course, has captured this entire discourse quite nicely. So my appeal is to all of you that when you get time, kindly have a look at it, and if you find any particular chapter relevant, you may read it also. So we begin with the concern that what are indicators and why are those needed? And here the context is of assessing water security. But similar concerns when one begins with asking that what do we mean by security, the questions of availability, questions of scarcity, questions of use, these come into the thinking. And then are we tried trying to think about an index like the water poverty index for measuring water security? And then if that is the question also comes in that who uses the index. Hmm. So index always has some kind of target audience, and if the audience is diverse, the indexes might be complex. And if index tries to address a specific audience, then the nature or the level of difficulty or the complexity of the index might vary. So, target audience is one major factor which influences the type of index, and then accordingly the need of indicators might get changed. So if you're talking about, say, general public and media, your indicators need to be quite simple. You might desire a small number of indicators in the form of index which should be easy to understand, and those should represent the issues of direct concern. But if your audience is policymakers, decision makers, and resource managers, if this is a category which I won't call as a homogeneous category, but where the understandings might be closer to each other of these people, then your indicators are directly related to policy objectives. Those should tell you, those should enable you to measure the performance, or those can be related to the evaluation criteria of a particular program, a particular scheme. Hmm. Or those might be directly talking about target values. And your then category is technical experts or senior advisors, then your concerns for building an index or the indicators which are processed within the index or in the index might be much more complex. because technical experts and science advisors won't get a clear picture just by a small number of indicators which subsume the reality, which is quite diverse, or aggregate numbers. They might be interested in raw data. Hmm. They might be interested in highly detailed and complex indicators. And the emphasis might be on scientific validity, more detailed and nuanced understanding of the reality, and also the complexity. So, with this understanding, if we go back to the idea of building an index for water security, within the audience itself, there is so much of diversity that if you want to give some kind of a message to people in Orissa, vis-a-vis if you want to give some kind of a message to the ministry in Delhi, or if you want to give some kind of a message to the scientists only in Maniri, you might need different levels of indicators or different types of indicators with a very different approach targeted to each of the audience. Let's look at some examples. The first example I would like to present here is one such index, which is quite famous in the water sector, which is called Water Stress Index. And Water Stress Index mainly defined as the fraction of the total annual runoff available for human use. Well, this has been developed by Falkenmark in 1989, and it was quite popular. It got quite popular very soon because it was giving a certain kind of threshold with certain categories, of say no stress, stress, scarcity, and absolute scarcity. We are going to look at each of this quickly in terms of what threshold numbers she came out with and why those were felt relevant by many countries and the people or policymakers or scientists who tried to use it. So her assumption was that the total annual runoff is something which engineers try to capture by impounding water in the form of dams, which is then further used for cities, for irrigation, for industry, etc., etc. And hence it would provide a good kind of indicator in terms of availability of water for people. So she defines water stress index as the fraction of total annual runoff available for human use. Multiple countries were surveyed and water usage per person in each economy was calculated. I mean, she calculated with her team while developing this. And based on the per capita usage, then the water conditions in an area could be categorized as four categories: whether there is a stress, water stress, whether there is no stress, whether there is a scarcity situation, and whether there is an absolute scarcity situation. Each of these are progressively problematic, or it indicates some kind of concern or danger in terms of availability and use of or usable water basically. So in the form of a table, it looks like if more than 1700 meter cube per capita water is available, then there is absolutely no stress in terms of water. If the condition is such where your availability is between 1000 meter cube to 1700 meter cube, then it is a stressful situation. But if it further drops up between 500 and 1000, then the scarcity situation emerges. And then if it falls below 500, then you are in absolute scarcity. So this is a water stress index, quite simple, based on the measurement of the total annual runoff available for human use. And because it was easy to understand, it got quickly popularized and people started understanding it with the systems which they had for measurement of the annual runoffs. Let us look at another example, and this example is of the basic human needs, in which water scarcity index is a measurement of the ability to meet all water requirement for basic human needs was the concern. It is quite descriptive, less of a measurement there. I'm not saying that not at all measurement, but if you look at the criteria of or on the basis of which this basic human needs approach has been considered here. First criteria is of minimum drinking water requirement, and it is based on the data from National Research Council of the National Academy of Sciences. Uh, which country it is at, don't exactly remember, but it must be US. It was used to estimate the minimum drinking water requirement for human survival under typical temperate climate. So temperate means not definitely US, it is some kind of a country from a global south with normal activity, and it was about 5 liters per person per day. Basic requirements for sanitation, they took into account various technologies for sanitation worldwide, and effective disposal of human waste could be accomplished with little or no water if necessary. However, to account for maximum benefits of combining waste disposal and related hygiene, as well as to allow the cultural and societal preferences, because that is also one of the important criteria, a minimum of 20 liters per person per day is recommended, and that's their sort of assumption for basic requirement for sanitation per capita. And then comes the basic water requirement for bathing, and studies suggest that the minimum amount of water needed for adequate bathing is 15 liters per person per day. And also then the basic requirement of food preparation, and there they have considered it around 10 liters per person per day, and that's how basic human needs considers 50 liters per person per day. And if that much water is available, obviously on the basis of which the needs could be calculated for entire population and come arrive at a threshold, then that was one understanding of, say, scarcity index. So you can always calculate that for a population of 1 million, if 50 liters is per person per day is not available, and if it is less, then you are into a scarcity situation, or you are not into a scarcity situation. The third example is of social water stress index. Here the Falkenmark's indicators have been considered as a base by Olson in the year of 2000, and he integrated the concept of adaptive capacity of a society to consider how economic, technological, or other means affect the overall freshwater availability status of a region. And because of this adaptation idea or concept, he looked at the capability of a society to adapt to difficult scenarios, which is also a function of distribution of wealth, education opportunities, and political participation. I think all of this we know that. And then based on that, he presents that how this idea has been further developed in the human development index. And I think we had some discussion about human development index in the water poverty lecture, so I won't repeat it. But one part of HDI is the social water stress index. That's what he's trying to present here. And if you go further, you will find that many such indicators actually exist. Water stress indicator, which we just looked at. Then there is vulnerability of water systems indicator, which is at the watershed level. So the scale is watershed. Basic human needs index, that is country scale. Water resources vulnerability index, that is also at the country scale. Indicator of water scarcity. Water availability index, which is at the regional scale. Index of water scarcity, another uh, uh, expansion of the earlier work by OECD. Then we know water poverty index by Sullivan. Then index of watershed indicators, US EPA developed it in 2002. Relative water stress index, which has a comparative angle but still at a country level, and Canadian water sustainability index by PRI in 2007, which is at the community scale, which is not at the country or regional scale. So several indicators have been proposed in last 20 years, and especially between the decade 2000 and 2010, and later after that this water security actually started coming in. But before water security team started arguing for its own approach, and when they started looking at various indicators, they found certain issues with the existing indicators, or they had certain observations about them. And the first observation was about water quality indicators are more prevalent than water quantity indicators. Ecosystem health indicators are more prevalent than human health indicators. Surface water indicators are more prevalent than groundwater indicators. there are very few integrated which actually try to combine surface and groundwater indicators, and governance indicators are very sparse and very poorly developed, because quantification of qualitative angles of governance or performance of governance is very difficult. Might be that is one of the reasons why you don't get many indicators in the water governance per se, and infrastructure indicators are very limited in number and also in scope. And so there is every argument, there is every reason that based on the earlier attempts and these um, limitations of them, why one should not try and develop a comprehensive indicator. Again, when we were trying to discuss about water poverty, we looked at the entire ambition, how comprehensive, how relevant, how diverse, how relevant to diverse situation an indicator should be. A similar approach with which people are beginning here, and then it would be very interesting to see that where they land and how do they conceptualize, and that we are trying to do or trying to understand here in this. And one more recording would be left, which I would be presenting after this to you. But still I appeal that try to at least browse through that book. That book is very interesting because this discourse is not settled. You might develop some interest in some of the angle with which the water security has been understood or critiqued, and I would be happy if you have your own stance on it, whether it is critical, do you accept part of it, whatever it is, but having your own opinion would be very important, because this is not a settled discourse, this is not an established concept, and people are still grappling with it. It is something which is still fluid. That's the reason why I'm appealing all of you to go through that book whenever you get time. So I end here and try to shift now to the concepts of blue water and green water, which were coined by Falkenmark, where the fourth bullet of this current slide, where they find one of the limitations as the existing indicators do not integrate the surface and groundwater spheres and do not measure them and do not try to capture them holistically to understand the availability, scarcity, sustainability, use, various concerns about water or water security or insecurity. So we are going to begin with that now after this slide. So the terms green water and blue water have specific meanings as defined by Falkenmark. We need to understand the definitions, and then only we would be able to understand what does she mean by blue water and green water partitioning, how both independently or combinedly affect the development. And although she mainly talks about green and blue in the context of food production, also she considers other aspects of use of blue water. So all of that we will get in, but let's look at the definitions. She defines blue water as the fresh surface and groundwater, both surface and ground. So blue is both. In other words, the water in freshwater lakes, rivers, and aquifers. Green water is then what? The precipitation on the land that does not run off or recharge the groundwater. Here, precipitation comes as a source, but is stored in the soil or temporarily stays on the top of the soil or vegetation. Eventually, this part of the precipitation evaporates or transpires through plants. So, green water can be made productive for crop growth, although not all green water can be taken up by crops, because there will always be some evaporation from the soil, and because not all periods of the year or areas are suitable for crop growth. So, but still, that is the green water. Hmm? So, what then would be green availability? The evapotranspiration of rainwater from land minus evapotranspiration from land reserved for natural vegetation, and minus evapotranspiration from land that cannot be made productive. So very clearly, when you minus natural vegetation and from the land that cannot be made productive, what remains is the water for evapotranspiration of the water, which happens through agricultural practices. So clearly she is talking here about agricultural context. Then the blue water scarcity is the ratio of blue water footprint. Now I do believe that all of you understand the concept of footprint. I don't explain that here once again. The ratio of the blue water footprint to blue water availability. Blue water scarcity varies within a year and from year to year because of the seasonality, because of the variability in the climate, rainfall, etc., etc. And also the use, also the number of people using it per unit. So she uses a particular term called water crowding to that. It is going to come in the subsequent slides, so right now I do not dwell on it. Then comes the green water scarcity. The green water scarcity is important. The ratio of green water footprint to green water availability. Now, green water availability, these both concepts have been defined above, and on the basis of that, she is talking about green water scarcity. It's slightly complex to understand, but once again, if you go through, you will clearly be able to capture it. So green water scarcity also varies within a year and from year to year, and there are various reasons like dry climates, droughts, dry spells. There can be man-made green water scarcity also. So here her appeal is to understand the concepts blue water and green water, understand them in terms of availability, and then measure them, because unless you measure it both from the sense of availability and from the sense of requirement, you won't be able to understand the situation in terms of whether the situation is water secure or insecure. Hmm. So measurement is anyway important. It is a scientific way of understanding things. So, and but you need better concepts to measure. You need concepts which would help you to understand the surface ground dynamics or surface and ground interaction, and that interaction she tries to understand through the concept of green and blue partitioning also. We'll come to that in the subsequent slides. So let us first look at the blue water scarcity in the form of an index. So here blue water scarcity is basically, in other words, used to availability ratio. And if one wants to understand water security or framings of water security that focus on quantity and availability of water, then those are linked with the water security assessment tools. And we are going now towards that assessment orientation. She says that the most well known assessment tool to date combines two indices. One is for water stress, and second is for water shortage. The first index of water stress evaluates the ratio of water use to availability and estimates demand driven apparent scarcity. I know this is slightly complex, so I want to once again appeal and draw your attention, as otherwise I do in the offline classes. Scarcity is a relative term. Hmm. Scarcity always depends upon the demand. So, if your demands are low and water is abundant, you are actually not in the scarce situation. But if water is abundant but your demand is more than abundant, I mean, if water is say x, and if your demands for water is more than x, then definitely you will fall into the scarcity situation. So when she is using here demand driven apparent scarcity, she is basically hinting at the population growth, and second is the improvement in the standard of living of the population, because standard of living would then indicate at diverse kinds of needs which require water, maybe production also. I mean, standard of living in that sense includes all the riches and luxuries after a particular point. So the water stress index she tries to calculate, which she says it evaluates the ratio of water use to availability and estimates demand driven apparent scarcity by measuring how much water is withdrawn from rivers and aquifers, which are the blue water resources. That is one. Second index is of water crowding, hmm, in which water shortage estimates population driven real water shortages by measuring the number of people that have to share each unit of blue water resource. And here she uses sufficiency of water supply for humans as the primary gauge. Now sufficiency and scarcity, the same dimension which I talked about. It depends on really what standards of living, what is the level of economy, what is the level of demand for agriculture, industry, and consumption. All three measures would basically define the demand and the sufficiency thing. And if then on the basis of that whatever threshold you arrive at, she has arrived basically, and she is talking in terms of numbers. It is not just an assumption. It's all based on the calculation of water consumption across the world in different economies and different standards of living, and basically processing it in some kind of averages and arriving at a particular threshold. And we had looked at that in the water stress indicators which she presented in the earlier slide, the water stress index I am referring to right now. So if that is the sufficiency kind of threshold, then how water crowding can happen? Hmm? This is explained in a more detailed way in the chapter in that book which Marin Falkenmark has written. So in this graph, she presents those two indexes which we just looked at in the earlier slide as two dimensions of water security, and she tries to present the relation between the two. On the vertical axis, she plots the use to availability ratio. That means what fraction of water is being used of the total available water. Of course, the blue water we are talking about. And the horizontal axis tells us about the people per million cubic meter per year. And she is trying to basically show using that the concept of water crowding. Water crowding in simple terms is if you have, say, 10 million cubic meter water as one unit and there are 100 people, then whether you are in abundance situation or what kind of situation you are, if there are 1,000 people, if there are 1,000 people, if there are 1 lakh people, if there are 1 million people, so but the unit remains same as 10 million cubic meter, then per unit your population is increasing. To express that phenomenon, she is using the term called water crowding. Quite simple. Okay. So coming back to this graph of two dimensions of blue water scarcity, she shows us the population driven shortage or water crowding on the horizontal axis and demand driven scarcity or water stress in the vertical axis. So obviously here she is trying to capture both scenarios. You know, there are countries or regions of which population is stagnant. So population has not been changing, or in some countries actually population was even on the negative side, negative growth or declining, or even with the stagnant or declining population, the overall use of water has been increasing. I mean, this phenomenon is quite common in some of the developed Western countries. In such cases, what is happening is out of the total available blue water, the actual water consumption is increasing. So the use to availability ratio is changing or increasing, I would say. And to capture that, she plots that particular aspect on the vertical axis. So if you look at the square in the graph on the left side, left bottom, she plots it as moderate or low stress if the population per million or people per million cubic meter per year is around 600. If you want, you can calculate on a sheet of paper that how much is the million cubic meter in terms of liters, and if that is one unit, she is talking about here 600 persons per million cubic meter per year. Why per year? Because water is considered and we know that it is an annually replenishable resource. And with that, if used to availability ratio is around 40, then that situation she has classified as the moderate to low stress. So there is no great pressure in terms of water or there is no great scarcity in terms of water, and that is fairly manageable phenomenon. If with the same level of population of persons per million cubic meter per year, the use to availability ratio goes up to 70, then the left up or left middle side box would we can look at, that she categorizes as the high water stress. But here again, she is still talking about a stagnant population, 600 per million cubic meter per year, and within that, the consumption of water is increasing, maybe because of changes in the standard of living. So, this would give you some kind of an understanding about how to regulate the consumption, how to regulate the water use, etc. etc. because you are falling in a high water stress kind of a situation. The left top box, actually it is not a box, it is an entire graph, that entire row captures, where she has written over appropriated oblique environmental flow, because she considers that 30% of the entire blue water should be considered as an environmental flow. She has considered that argument by environmentalist, and she has integrated that in the this particular graph. So if your consumption goes up than 70% ratio, then you are definitely abstracting or exploiting the environmental flow, is the argument she is making. On the other hand, there are also countries where the population is increasing and use to availability ratio is not changing, maybe because of underdeveloped technology, maybe because there is no great groundwater abstraction, maybe because strict regulations or whatever other conditions are. So I'm not, or she is not getting into the details of those conditions, but just she is considering that situation to show us the other scenarios. So with the 40% as used to availability ratio, if from 600 to 1000 the jump is of people per million cubic meter per year, or it goes beyond that, then the water crowding phenomena start happening, in which you find a scenario of chronic water shortages. Now chronic is chronological, that means every year you will get into water shortages, same because of the uh, seasonality aspect, or because water is annually replenishable, there is a water cycle, there is a hydrological cycle, etc. etc. That has been sort of reflecting in the use of term of chronic water shortage. But if your population also increases, then your persons per million cubic meter per year also goes on increasing, and simultaneously your consumption also increases. So it jumps from 40 to 70%. Then you are into severe water shortage, and then that is going to be an alarming situation. In this graph, these slanting lines, there are five slanting lines, and one is the red line. At the top of that slanting line, you see that 200 meter per cube person per year has been written, and all of that actually is plotted as per capita water use in 1 year per year. So at different points, those slanting lines show the level of use actually per capita, just to give an understanding of, if you are in a severe water shortage, what amount of water per person per year would be available. If you are in the high water stress zone or a moderate to low water stress zone, what would be the per capita water available per year, using the flow unit of meter cubes. But this is one particular aspect of understanding the entire spectrum, which she argues that the definition of water security should consider. This is of blue water scarcity. But there is also green water scarcity, and before that, we need to understand what is the green blue water partitioning, and how the green water is separate than the blue water, and how it gets separated during the and after the precipitation. So you can have a closer look at this graph when you have time, or you can pause this while I'm talking and also have a look at it. But what she argues is that the rainfall is actually the undifferentiated freshwater resource, which is not still with, we don't know whether what part of rainwater is green, what part of rainwater is blue, but it gets partitioned in a green water resource as moisture in the unsaturated zone, and in a blue water resource in aquifers. Now, having gone through the groundwater course, I do understand that you understand these terms of what is unsaturated zone and saturated zone, etc., etc. I'm not again going into the details of that, but moisture in the unsaturated zone is the green, and in the blue water resource, then it would get aquifers, lakes, wetlands, and impoundments. We had already looked at it in the earlier slides when we looked at it, the definitions of all of this. So water in the unsaturated zone then generates the flows. Flows as green water flow from terrestrial biomass producing systems, crops, those are forests, those are grasslands, those are savannas, and the blue water flow in the rivers through wetlands and through base flows from the groundwater. Now again, you know, whatever flows through the river maybe after monsoon is actually base flow, is the new argument which Himanshu has taught in his classes. And this is how green and blue water partitioning actually happens. So if one looks at it in a drainage basin perspective, the precipitation over an area represents the proper water resource, part of which is consumed in the plant production and evaporation from moist surfaces, that is the green flow, and the surplus goes to recharge the aquifers and rivers, that is the blue flow, which is also available later then for the societal use and the coastal ecosystems. And just we looked at the graph which actually was talking about the relationship between use to availability ratio and water crowding was about the blue water. But we also need to understand the concept of green water scarcity. And here, when we talk about green water scarcity, the focus is on the measurement of one agricultural water security or insecurity, since it is of the utmost importance for the food production. So, when we talk about green water, we are particularly talking about food production here, and which would be one of the inseparable element of understanding and calculating the water security of a particular region or at whatever scale. So she argues that crop production critically depends on the plant roots taking up the soil moisture. Hmm. Soil moisture is the green that we know now, and transporting it up to the leaves to balance the transpiration losses during the photosynthesis intake of airborne carbon dioxide. So, purely plant growth is thus a function of green water accessibility in the root zone. And here the green blue together has to be considered when one is trying to understand it from a security point of view, because under the conditions of deficiency of green water, blue water may be added as a complement through irrigation to achieve the green water security. Because irrigation is a common practice, basically irrigation increases the availability of the water in the soil in the form of soil moisture, and then it is basically used by the plants. So when she talks about challenges towards that, soil degradation, dry spells and climate variability, and also anthropogenic activities can affect the green water availability or scarcity. Like water crowding, which affects the overall blue water scarcity or blue water accessibility or situation. Here, these are the factors which are actually impacting the green water availability of scarcity. You know, in typical situations, the roots are disturbed by even dry spells, so that the root systems cannot take up the water in fact available in the root zone. So despite that water is available in the root zone, roots get disturbed because of the dry spells, and they, despite availability, cannot actually absorb water. This may result in huge water losses, because finally if that water is not absorbed by the roots, gradually it will get evaporated because of the sun from the soil. That's how she is saying that it may result into huge water losses. So green water scarcity is not just a function of availability, but it is also a function of soil degradation, it is a function of dry spells, it is a function of climatic variability, it is a function of other anthropogenic activities which can affect the availability. That is a major point she wants to raise in the context of scarcity and then security. She further talks about the issues in green blue partitioning and what kind of issues can produce disturbances in that partitioning itself, because partitioning again is a major function which makes or ensures availability of green water for food production and availability of blue water for, on one hand, complementing the green water losses, and on the other hand using blue water for various range of other kinds of activities, including industries, including everyday consumption, etc., etc., by human populations. So green blue partitioning is the focus she tries or appeals to bring in while understanding and planning for water secure situations. And further, she talks about that how population expansion or socio-economic development pose disturbances in green blue partitioning. And those disturbances could be, for example, land use changes. She talks about she gives an example of how deforestation in 300 years has actually resulted in decreased vapor flow on one hand and increased runoff. Now, runoff she is considering as a loss, and runoff to the order of 2,500 kilometer cube. Otherwise, we talk in terms of meter cubes, but 2,500 kilometer cubes per year. So land use changes is one of the major cause of disturbing the green blue partitioning. River flow depletion is another, and these are interlinked. Land use changes would disturb the partitioning. Partitioning would impact the river flow depletion. And then who is talking here about environmental flows? That is a further category which she accepts and argues for. So she says, I mean, with her team, of course, she concludes that a country's self reliance potential in, in terms of food production on current cropland is a function of green and blue water preconditions. In this slide, actually, there is a diagram which shows a country by country diagnosis of green and blue water availability for food production by 2050. And in this she has restricted the current cropland area. That means she has assumed that the cropland area is not going to increase by 2050. In this diagram, the horizontal axis shows the available blue water in terms of meter cube per capita per year, and the vertical line indicates the chronic water shortage indicator of 1000 persons per flow unit. Here the flow unit is meter cube. And the vertical axis, not the line, vertical axis shows the water available on current cropland areas with an upper slanting line indicating the total water requirement for food production on the current water productivity level. So the current water productivity level has been also assumed. Vertical axis shows the total available water, which means the green and blue both, and these all dots which you see on the graph are actually the countries. She has not revealed in this paper the names of the countries because that is not also the objective, but she is just trying to explain us the concept of water security for food production by the year 2050. So if you look at the left side parallelogram, which is the area marked by small a in the graph, where the availability of blue water per capita per year in meter cubes is restricted to 1000, and the total water availability ranges from say 1200 to 2500. I mean 12 or 1300 to 2500 are the meter cube per person per year. That's the area, or the dots in that area are the countries which are facing both kind of shortages. Those are facing the blue water shortages as well as the green water shortages. Whereas on the upper side of this parallelogram, where the area is has been uh, marked by the small letter B, is or are the countries which are facing green water abundance but definitely blue water shortage. That means simply their non agricultural water consumption is more, because soil moisture or green water availability seems to be pretty okay. On the right side in the zone C, definitely there are some countries, or there is some area in which countries are plotted which face the green water shortages and blue water abundance. And in the area D, obviously both green and blue both are pretty nice. I mean, both are adequately available, I would say. So by this kind of categorization of the countries based on certain assumption about availability of water for food production by 2050, when there are assumptions that the crop land area won't increase and water productivity level would also be remain same. Then what are the implications if this graph is shown to the respective countries, that boss, you are following in this region, that means that these are the shortages you would be facing or you are in such conditions. Then there are certain policy implications further she presents in her paper, and those are like, for the countries which face both kind of shortages, green and blue, the countries which are in the region A, she finds that 46% of the world population is currently in that, and the policy implications for them would be horizontal expansion, food import, radical water productivity increase, and food imports if are not possible, and if there are limitations in terms of horizontal expansion meaning the agricultural expansion she is talking about, and if there are limitations also in terms of increasing the water productivity, and if food imports are also not possible maybe because of economic situation, then they are going to be in the dire condition. Then there is only aid, international aid, which can save them. She finds around 14% of world population in the category B, where the policy implication for such countries would be upgrading the rain-fed agriculture and rainwater harvesting, because they are still facing blue water shortages, whereas green water abundance is there, and if they want to increase the food production, this is what they need to do. In the category C, she finds that currently 21% of the world population lies, and they have to expand irrigation because they have blue water abundance, but there is green water shortage. And generally, arid countries where there is extreme or middle level of aridities, which actually influence loss of soil moisture very fast, maybe some tropical drought ridden countries which cannot sustain on the rain fed agriculture. Basically, she is talking about such countries where there is some possibility still left to increase the use of blue water and make it available for food production. And in the category D, she finds that currently 19% of world population lies, which are actually good in terms of green and blue, and they should increase their food production. They can upgrade rain-fed agriculture, they can irrigate, expand their irrigation, and that's how she thinks that considering blue and green together can give you a certain understanding of water security, both for food production because that is basic, that is fundamental, and then also for other kind of uses of water. I think I would like to end this here just to give you a sense of how this water security team, I mean the team of scholars which is trying to develop the idea of water security, also brought in Falkenmark and her own understanding about how to measure the water scarcity from the angle of water security. And in that effort, how Malin Falkenmark itself moved further ahead from just a water stress index, which we looked at in the beginning of this recording, to combined understanding of green and blue water partitioning, the disturbance possibilities, and then making an or further developing those concepts to understand and assess the water scarcity situations. In the next recording, we would be talking more about the conceptual aspect of water scarcity, which goes beyond purely assessment point of view and tries to bring in also the qualitative angles of equity, equality, access, etc. etc. That would be the last part of this 3 lecture series on water security. Thank you.